that every racing car in the top formulae of motor racing must go through a series of mandatory tests. Here at the Motor Industry Research Association's headquarters in England, under the watchful eyes of a team of engineers and scrutineers, we're going to see the first of the 4 tests that a modern racing car, in this case a 1990 Lotus, has to pass before it can be raced. The car, complete with dummy driver, will be rammed into a concrete block to see how it stands up to a severe frontal impact. The car is mounted on a sled, which in turn is on wheels. The sled is attached to a series of weights which will drag the car into the metal-faced concrete. The whole operation is carefully monitored, of course. Sensors known as accelerometers are mounted on the car to measure its deceleration, while the damage will be carefully analysed by FISA official scrutineers from motor racing's governing body. The dummy, strapped into the cockpit as a driver would be, is not compulsory, but as the whole operation is on high-speed film, what happens to a potential driver is naturally of interest to the scrutineers, who examine the majority of cars that are involved in major accidents in motor racing. The chassis then has to be strapped to the sled for what may be its final test. In this instance, the chassis has been built to 1991 regulations, which involve the whole chassis rather than just the front section. A timing device measures the speed at which the chassis hits the wall, while there are 2 decelerometers to measure the G-forces at the moment of impact. 2 accelerometers are used, as this is obviously an expensive exercise, and should one fail, it's not something that can be easily repeated. Similarly, other instruments are checked and rechecked to ensure that the results are obtained and are easily analysed. The front nose section, as part of the structure of the car and its safety, is fitted, as this should contribute to the chassis strength. The car is rammed head-on into the concrete block, although circuit design over recent years has been carefully altered to prevent such impacts, so that most accidents with walls or Armco barriers are at an angle. For this reason, the relatively low speed of the impact, 22.4 miles per hour, is not significant, in that rarely would this impact occur anyway. But an oblique impact is rather harder to engineer. So the car is winched back into position. The driver sits almost as a driver would, but in this case, of course, it is a dummy. Finally, it is ready. It stood up well to the test with relatively little frontal damage, particularly to the survival cell, in spite of outward damage. Designer Frank Durney feels that the crash test has contributed to cars' safety.
Oh, there's no question. The cars are a lot safer now than they were before, and whilst you always make an attempt to make the car as safe as possible, the crash test has actually made people do very expensive experiments that certainly some of the smaller teams wouldn't have been able to afford to do if they weren't mandatory.
If this test should fail, what happens next?
If this test fails, you have to examine the wreckage and redesign those areas which were inadequate.
How has the development of monocoque construction contributed to safety?
Well, I think the materials we have available to us now are very varied, and we got quite a big choice of carbon fibre materials with different mechanical properties, for example, and Kevlar and what have you. But I really think the crash test is the thing that's helped most, because developing structures to be safer involves crashing them to see how safe they are. And previously, it was not something that was widely done because it was expensive and time-consuming and what have you. So by having it put into the regulations, it's forced us all to prove that we were making safe cars. We thought we were, and we tried to, but now we prove that we are.
Do these crash tests restrict a designer in his work?
To a limited extent, they do. You know when you're designing the car that the cross-sectional area of the front has got to be big enough to have enough material in there to pass the crash test. But one couldn't argue against it, because in doing so you're making the car safer, and as long as it doesn't give you a disadvantage compared with the other competitors, you can't disagree with it. It's got to be better.